Hello, this is Dr. Naveen Sundar from Karunya University, and today we are going to see a very important topic in computer architecture, that is mapping techniques. So there are three different types of mapping technique. Okay, so first is direct mapping, and the next is associative mapping, and third is set associative mapping. Okay, so these are the three types of mapping technique. Okay, so the mapping is none other than how the cache and the main memory which is associated with one another. Okay, so this is how we are going to see the different mapping technique, and also we will see what are the merits and demerits of this particular technique. Okay, now we will see about what is this direct mapping. So first we will see about direct mapping technique. Okay, so as I told you, the processor, okay, how the processor, okay, it will create the address, and it will first check with the whether it is present in the main memory or it is present in the cache. So first it will go and check with the cache. Okay, so first it will go and check with the cache. If it is not present, then it will go to the main memory. Okay, so we have to be very clear with the size of the main memory is bigger compared to cache. Okay, so when it is lesser size, then it will be easy for the processor to access fast. Okay, so that is the concept. The size of the cache is smaller compared to the main memory. So how the direct mapping between the main memory and cache, which is associated with one another. So first we will talk about the size, how we will calculate the size. See, for example, if the processor produces the address, okay, the processor produces the address which has 6 bits. For example, so it has 1, 2, 3, 4, and 5 and 6. If it is having a 6-bit address, it produces, and if it goes and checks with the main memory, okay, so consider it is a main memory means, so how many words it will have. So the addressable unit will be 2 power 6. So that means it is 64 words. Okay, so in the main memory you will have 64 words if it is a 6-bit address if the processor produces. So for example, so if you are taking 64 means 0, 1, 2, 3, and then 4, 5, 6, 7, like that it will go on, and next finally 60, 61, 62 and 63. So totally in main memory you will have 0 to 63 words. Okay, so that means 64 words it can hold, that is 2 power 6. So how you will have the addressing here? So you can make it like, so 64, how many in main memory we will divide it into blocks. Okay, so that is how you will tell. In main memory we will call it as a different blocks, but in the cache we will call it as like a line. Okay, so cache line. Okay, so this is how we will call. So when the main memory means it is 0, 1, 2 up to, okay, so 15. That means 64 divided by, okay, so that is the total number of words. Okay, and then each block will have 4 words. Each block has 4 words, that is 0, 1, 2 and 3. Okay, so that is the 4 words. Okay, so 64 by 4 means you will have 16 blocks. Okay, so this is how you will calculate the number of blocks. Okay, so that is a 0 to 15. Okay, so the processor, okay, having a 6-bit means, okay, so that is 2 power 6, that is 64 words, and how many blocks you will have, that is 64 divided by 4, that is the number of words in a block is equal to 16 blocks. Okay, so this is how it will be categorized. Okay, so for the direct mapping, then how many lines? Okay, as I told you, the line size, cache line size and the block size will be equal. Okay, so both has 4 words. So both has 4 words. As I told you, when a particular word which is present in the cache, if it is not present, okay, and the next it will go and check with the main memory. Okay, so it will go to that particular location and that particular word will be retrieved, and the copy of that particular word will be copied to cache. So the main idea of the next time the processor will go and check, it will not go to the main memory, but it will just pick from the cache. So that is the main focus. So the size of each block, okay, should be the same size of the line. Okay, but the size of the cache, which is smaller, the size of the cache is smaller compared to main memory. Okay, so this is how it is differentiated. So we have to clearly know that if the size is different, it can't hold all the data which is present in the main memory, right? So that's why we are going for this mapping. So this mapping, which are all the blocks that is associated with particular cache. So here we have to divide equally. Okay, so that is 16 means 16 divided by 4, that is the number of words, so is equal to 4. Okay, so the number of lines in the cache, it will be 4. So that when we make it like 4, okay, so 4 cache lines. Okay, 4 lines you will have. Number of lines in the cache is 4, and that is you can tell it like 0, 1, 2, 3. Okay, so this is how the cache line will be different, and the blocks is, number of blocks is 16 blocks. Okay, so these 4 lines, it's going to get associated with 16 different blocks. Okay, and so each cache line, it is going to associated with 4 different main memory. See, for example, if you are having 0, 1, 2, 3, okay, so you will have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, 12, 13, 14, 15. Okay, so consider like 16 word. How it is going to associate? So it is like 0 is going to associated with 0, and next is 4. Okay, and the next is it going to associated with 8. According to round robin, okay, it is going to associate. Okay, similarly 1, okay, how it is going to associate? That is with 1, and the next is it is with 5, and the next is with 9, and the next is with 13. So this is how it is going to associate. Okay, so that's why we are dividing equally in the cache. So easily we can say it is associated with 0, and the next is 4, 8, 12. Okay, and 1 is it is going to associate. So how you will tell it here? That is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Got it? So this is how it is going to get associated. So the cache line 0, it is going to associated with the block 0 and the 4th block and 8th block and 12th block. Okay, and similarly cache line 1, it is going to associated with the 1st block and number 5th block number and 9th block number and 13th block number. Similarly for 2 and 3. Okay, so this is how it is going to get associated. Got my point? So now you can clearly say that it is direct mapping. Okay, so what is the drawback of this direct mapping? So when even it is only reserved, okay, so this 0, this line, okay, cache line is reserved for these blocks only. Okay, so even if the any one of the block which is free and the remaining block, say for example for 1, okay, so for 1 already any one of the block is filled, okay, all the 4 words which is filled. If we want to store the next block, so that is the 5th block, if we want to store try to store any one of the free spaces, it cannot be done because it is reserved only for cache line 1. Okay, so this is a drawback we will face. So mostly because of not having adequate space, we can't store the word in the cache. Okay, so that is the main drawback we are facing in the direct mapping, and how to resolve it. Okay, so first for I will tell you with a small example. In the processor, when you make a processor, okay, as I told you, it is a 6-bit, and how we are going to have a mapping here, okay. So that is very important. So as I told you, the processor will have a 6-bit address, okay, 6-bit address. How we are going to categorize? For example, if you are having the last 2-bit, okay, so that will be called as a block offset. Okay, so that will be the block offset. First, I tell you how the processor address going to get searched in the main memory. Okay, so that is the block offset, and the remaining 4 bits. Okay, so that is the remaining 4 bits will be called as a block number. Okay, so block number, if you are giving as a binary word 000 0001 0010 up to 1111, right? So this is how it will be arranged. This is the block number. Okay, so the block number is 4 bits. See, for example, if you are putting 001000, okay, so if it is, this is the processor address length. Okay, if you consider this is the processor address length, okay, how we are going to make it? So this is the, as I told you, this is the block number. Okay, so immediately the processor will go and check with 0010. So it is the block number 2. Okay, and we are telling it as like block offset is 00. As I told you, it can hold 4 different words. It can hold 4 different words. Okay, so either it can be 00 or 01 or 10 or 11. Okay, so it can hold 4 words. So it will check the block offset, that is 00. So 00th word will be taken. Okay, so this is a word which is taken from the main memory. Okay, so this is how the processor, with the processor length, it will go to the main memory, and that particular word will be retrieved. Okay, but for the catch, how we are going to do it? Okay, so for the catch, for the same processor address, okay, so for the same processor address, how we are going to make it? So here we are dividing again these two. Okay, so this is like a word offset. There we are telling it as like a block offset, but here we are telling it as like a word offset, that's all. And then this is like a catch line number. Okay, and this is the tag. Okay, so this is how it is going to make it. Okay, in the catch, you are having 4 different catch line. Okay, as I told you, it can hold either 0 or 4 or 8 or 12, which will be associated with this the first thing. Okay, so it will go to the line number 10. So line number may be 00 01 10 or 11. Okay, so first immediately the processor will go and check with which is present in 10 or not. Okay, whether which is present in 10 or not. Okay, so directly it will go and check with the 10 if it is present or not. And the next is we are having tag. Okay, so as I told you, you have 4 different words. So okay, so 4 different words. See, for example, here it is a 0 1 2 3 and then 4 5 6 7 8 9 10 11 12 13 14 15. As I told you, okay, so these are this particular catch line can hold 4 different blocks, as I told you, right? So now it will consider the tags. Okay, so the first one will have the tag 00, and the second one will have the tag 01, and the third one will have the tag 10, and fourth one will have the tag 11. Okay, so that is how it is going to check with which particular tag it belongs to. Okay, so 00. So that means if the tag is 00 means then the catch hit occurs. So it can, if it is 01, even the line number is correct, but the tag, if it is not matches, then we will tell it is the catch miss. Understood? Okay, so if the catch hit occurs, so 00 is present and the catch line also is present, then it will have 4 words. Okay, as I told you, for each and every block, it have 4 words. Okay, so that particular 2 can be 0, 0, 0, 1 and 1, 0 and 1, 1. Okay, so as I told you, 4 different words it will have. So the next is the word offset. So 0, 0, the first word will be taken. Got my point? Okay, so this is how the processor length, it will go and check. First, it will go and check with the line number. Okay, and the next is whether the tag which is matches or not, and if it matches, surely the 4 words will be present, and which word to be picked based upon the word offset, right? So this is how the direct mapping will be work. Okay, but I told you the demerits of the direct mapping is sometimes because it is completely mapped. Okay, so this particular line which is reserved for these 4 different blocks only, even it is free, it cannot hold any one of this block in this thing. Okay, so that is the demerits in direct mapping. In the next section we will see about what is the associative mapping and set associative mapping. Thank you.